How would you multiply 9 with 8? Some of you have probably memorized the multiples of 9 and know the answer. We know that it is 72, but in this session, we will understand multiplication in a very different way. Will this different way help us? Well, let me put it this way. Understanding this technique will help us solve problems like 998 times 997 in about 5 seconds. Yes, without a calculator. You don't believe me, do you? Give me around 2 minutes to change your opinion. We use the concept of base to solve multiplication problems quickly. And bases are generally powers of 10, like 10, 100, 1000 and so on. When we are given the multiplication problem, the first thing we should ask ourselves is, which base is close to both the numbers? Here, both numbers are close to 10, so we can say that the base is 10. Once the base is decided, life becomes really easy. First, we subtract the base from each of these numbers. Subtracting the base from the first number, we get 9 minus 10. That equals minus 1. We write it next to that number. Next would be 8 minus 10. That equals minus 2. These two numbers tell us how far these two numbers are from the base. 9 is minus 1 units away from the base and 8 is minus 2 units away from the base. So the initial two steps, choose the base and subtract it from the numbers. Once this is done, just make a partition like this. On the left, we write the sum. What sum? The sum of these two numbers or these two numbers. Both will result in the same answer. Either 8 plus minus 1 or 9 plus minus 2. Both equal 7. So we write a 7 on the left. On the right, we have the product of these two numbers. Minus 1 multiplied by minus 2. And that equals 2. Yes, we should also consider the sign when we multiply these two numbers. There you go. We have the answer. 9 times 8 is 72. The steps are simple. We find the base, then subtract it from each number. Write the sum on the left and the product on the right. Is there anything we need to be careful about here? Yes. On the right, the number of digits should be equal to the number of zeros in the base. Here, the base has 1 0, so we write just one digit on the right. Don't worry, everybody thinks this is difficult at first. So let's quickly solve a couple of problems and you will see how simple this technique actually is. Say we want to multiply 98 with 97. Both these numbers, as we can see, are close to 100. So the base is 100 here. 98 minus 100 is minus 2 and 97 minus 100 is minus 3. Then we make a partition. On the left we write the sum and on the right we write the product. 98 plus minus 3 is 95. Even 97 plus minus 2 will give us 95. And minus 2 times minus 3 is 6. So should we write a 6 here? Don't forget, the number of digits on the right will be equal to the number of zeros in the base. As there are 2 zeros in 100, there will be 2 digits here. 6 will be written as 06. There's your answer. 98 times 97 is 9506. Find the base, find the deviation, find the sum and find the product and we get the answer in a few seconds. Okay, let's try solving a problem with slightly bigger numbers. 9996 times 9997. Why don't you try this? Remember the 4 simple steps. Find the base, find the deviation, find the sum and find the product. I give you 10 seconds. Both numbers, as we can see, are close to 10,000. So the base will be 10,000. This number is minus 4 units away and this is minus 3 units away. Then we make the partition, sum on the left and the product on the right. This plus this is 9,993. The sum of these two will also give us 9,993. The product will be minus 4 times minus 3, which equals 12. The number of zeros in the base is 4, which means we will have 4 digits on the right. 12 will be written as 0012. That's our answer. The product of these two numbers will equal 99930012. Wasn't this quick? Faster than a calculator, you think? Notice that in all the examples we saw, both numbers were below the base. 98 and 97 were below 100. 9,996 and 9,997 were below 10,000. We will look at a couple of more examples in the next part of the session. Don't forget the steps. Find the base, find the deviation, find the sum, and find the product. And we get the answer.